Hurricane Juan's impact on Point Pleasant Park's tree density, diversity, and species abundance. This is a presentation by Brooklynn, Sophie, and Maeve, and we are doing this under Dalhousie University. Point Pleasant Park is an urban park located in the city of Halifax, Nova Scotia. This park rests at the edge of the Halifax Peninsula and overlooks the Atlantic Ocean. In 2003, Category 2 Hurricane Juan struck this park, which led to a loss of trees and canopy cover. This put the park into a state of secondary succession, which is the process of plants recolonizing an area after a disturbance. Today, this park has a large forest ecosystem, which is classified as being either an immature IH6 or MW2, which means the forest consists of intolerant hardwood classifications and mixedwood classifications. An IH6 forest type consists mainly of white birch and red maple trees, and an MW2 consists mainly of red spruce, red maple, and white birch trees. Therefore, Point Pleasant Park consists mainly of these three tree types currently. Before Hurricane Juan hit, the park mainly consisted of red spruce, followed by hemlock, white pine, and red oak. The loss of many of these trees during the hurricane is what led to the growth of new species. The hurricane impacted the tree diversity, density, and abundance of tree species. The tree diversity and tree species abundance were altered through the destruction of lots of older trees during the hurricane. In the early stages of succession, shade-intolerant species with high dispersal techniques are favored as they are able to grow in this environment with a lack of canopy. This differs for a developed forest, as trees that are shade-tolerant and longer-lived thrive more in this environment. This park is of significance to the Mi'kmaq peoples. This park used to be a spiritual place for Mi'kmaq gathering. It also used to serve as a hunting or fishing ground for Mi'kmaq people to obtain their food source. The objectives of our study is to see how Point Pleasant Park has changed since Hurricane Juan destroyed an abundance of the forest ecosystem in 2003. We want to determine what stage of succession Point Pleasant Park is currently in by looking into how tree density, dominant species abundance, and species richness have changed since the hurricane.
Dalhousie students from Introductory Ecology visited 6 sites in Point Pleasant Park. Tree species and diameter breast height were recorded. The density of these 6 sites were taken every year from 2004 to 2024, excluding 2005, 2007, 2016, and 2020 due to circumstances that made sampling impossible.
The first results we are looking at is related to tree density following Hurricane Juan. The null hypothesis is that tree density has not been impacted by Hurricane Juan and has had no change in the last 20 years. The alternative hypothesis is that tree density plummeted in 2003 following Hurricane Juan and has steadily increased every year since. In the 2018 study done by Berg, Zarnoj, and McNabb, tree density was lower in areas affected by Hurricane Opal than in unaffected areas. The study discusses how the open gaps in the forest from the hurricane allows for increased sunlight, which facilitates growth, and therefore it would be likely that the tree density will increase over time with new growth. When looking at the graph, we can visualize a gradual increase in tree density since 2004 until today. In 2004, the tree density was near zero. This relationship is positive as the R-square value is 0.4926. The p-value is low and the f-value is high at 81.6, which demonstrates a positive correlation between tree density over time. This information rejects the null hypothesis. As the forest reaches its climax community, the tree density will continue to increase. Eventually, the density will plateau and remain at a steady level. As the canopy fills up, there is less access to sunlight for newer growth species, which will slow the growth rate. There is also more competition for resources like nitrogen and phosphorus, which will also lower the growth rate or prevent any new growth.
So question 2 asks how the density of dominant tree species changed over time and what will change as the forest becomes a climax community. To answer these questions, we made 2 alternative hypotheses. One was that there had been a significant correlation between density of red spruce and the time passed since 2004, and the second hypothesis stated that there was a significant correlation between the density of red maple and the time passed since 2004. And then both null hypotheses stated that there was no correlation, significant correlation in each respective species. Statistic results showed a positive correlation between both species density and time passed since 2004 for red spruce and red maple. The low p-values at 0.009 for red spruce and 0.002 for red maple prove this correlation, and it's also supported by their R values. Though both species densities increased, red maple's population increased drastically. Starting at a population of 0 in 2004, it averaged a density of 31.6 across the collected sites in 2024. Red maple's R-squared value is higher, showing a higher correlation with density and time passed, and these results align with the species characteristics. Red maple colonizes disturbed areas first. However, red spruce is expected to return as the dominant species in a climax community due to its long lifespan and shade tolerance.
In question 3, we are trying to answer how species richness in Point Pleasant Park has changed over the last 11 years after Hurricane Juan. The null hypothesis for this experiment is following Hurricane Juan, there will be no sign of significant change in species richness. An alternative hypothesis is there, in fact, will be a significant change in species richness following Hurricane Juan. This study was performed to determine how species richness has changed in Point Pleasant Park since Hurricane Juan in 2003. The species richness was calculated annually over 6 replicate sites from 2004 to 2024. Species richness increased by 0.5294 a year minus 1,059.4 in Point Pleasant Park since 2004, with an R-squared value of 0.6051. We can see there is a positive correlation with time and species richness shown in Figure 2. The R-squared value indicates a significant increase in species richness from 2004 to present day. Therefore, we can reject our null hypothesis and adopt our alternative hypothesis that there is in fact a significant change in species richness after Hurricane Juan. We can see on the graph how low species richness was following the disturbance. However, as time progresses and pioneer species distribute, we can see a gradual increase of species richness over time. Light availability from the canopy opening would allow for shade-intolerant species to grow where they couldn't have before, promoting new species growth. As species richness moves towards a climax community, it will follow successional theory in the sense that species richness will continue to increase until the forest reaches maturity. A climax community is defined when succession produces a stable community, promoting a state of equilibrium between the dominant species. The current trends in the graph show a constant increase, so the forest is not yet fully mature. In my prediction, as Point Pleasant Park moves towards maturity, the species richness will begin to slow. As dominant species take over and regulate the growth of other tree species, the forest will settle into an equilibrium. Therefore, the species richness will remain at a constant unless other factors such as disease or pollution disrupt the population. To conclude, the results of our collected data represent an Acadian forest at mid-successional stage. There is still a mixture of early and late successional trees, both dominating the forest, as well as a constant increase in species richness and diversity. These factors are common characteristics of a forest in mid-successional stage. Point Pleasant Park is an urban park, therefore the succession of trees was influenced by humans using the current park management plan. This included planting thousands of native tree species seedlings after Hurricane Juan, ensuring the species native to the forest were growing in the successional stage. They also removed non-native tree species such as the Norway maple and the European white poplar in order to promote native species growth. Two-eyed seeing has been known to promote collaborative approaches in forest restoration with deep knowledge of the forest's natural cycle and recovery. With this knowledge, we can create immersive park management plans best suited for the environment.
We would like to acknowledge that Point Pleasant Park and Dalhousie University is on traditional Mi'kmaq territory, and we'd like to thank Allison Schmidt for providing us with the data and grants for the study, as well as including us in the data collection process.
Thanks for listening to our presentation.
So there are a couple different things that could explain the change in densities and ultimately the change in dominant species in trees, including disturbance tolerance, nutritional needs, shade tolerance and lifespan, specifically referring to this data and this study. Red maple are the first to colonize disturbed areas. So they're pioneer species, which would explain them doing well after the hurricane. However, red spruce are more shade tolerant, so they're able to thrive even with a canopy more than red maple. And they also have a long lifespan, which would allow them to gain dominance over time and potentially outcompete other species that couldn't handle shade as well. So, yeah.
Question 2. The 6 sites for the study were chosen because they were heavily altered by the hurricane. However, sections of the old-growth forest still remain in Point Pleasant Park. Do you think the existence of these neighboring climax forest communities contributed to the process of succession at our study sites? So, old-growth forests are very important for biodiversity and ecological recovery because they have greater genetic diversity and reproductive fitness than the early successional phase forests. The old-growth segments that survived Hurricane Juan would have helped speed up succession in Point Pleasant Park, as they would contribute to seed dispersal as well as help maintain the forest habitat. The seed dispersal helps replant new trees to fill the spaces that were damaged. The presence of old-growth segments also provides habitat for the species to remain in the park in these sections. For example, when looking at tree density, the old-growth forests increase seed dispersal in the park, which would help lead to the increase of tree density over time.
The European white poplar is a medium-sized deciduous tree with a lifespan up to 400 years. The poplar produces a lot of seeds and has very fast root growth, making it a top pioneer species and would have colonized Point Pleasant Park fairly quickly. After Hurricane Juan created such a big disturbance, this would have opened up the tree canopy, providing the poplar, which is known to thrive in shade-intolerant conditions, a chance to colonize quickly. The poplar would have been a top pioneer species. As for the Norway maple, it is known to have a fast early growth rate and a capacity to withstand urban impacts. The Norway maple is shade tolerant and adaptable to temperature extremes, so it is known to perform well in municipal parks. It has many competitive advantages over native maple trees because of its effective seed dispersal, as well as the fact that they germinate quickly. If the park management team had left the Norway maple, it would have outcompeted many species in Point Pleasant Park. It would have outcompeted the now dominating species, red maple. Therefore, the succession of native trees would have been completely disturbed.